All right, folks, how you doing? Welcome back. So we're now returning to the Mars mystery, and this is the murdered planet, the mother of life. Disclaimer: under Section 107 of the Copyright Act 1976, allowance is made for fair use for purposes such as criticism, comment, news reporting, teaching, scholarship, and research. The mother of life. So Hancock states that science has yet to properly explain how life began, but there is agreement on certain fundamental points. Mars today is dead, dry, and cold, with the average temperature at minus 23 degrees Celsius, with no liquid water on the surface. Hancock also states that since close-up photography began, Mars has shown evidence of former lakes, oceans, and rivers, and also signs of catastrophic floods, which once ravaged the planet's surface. So here you've got an image of what Mars used to look like when it had oceans. And there's some very interesting and revealing topographical images there. Ice, dunes, and storms. So Hancock points out that even under favorable conditions, telescopic observations can be misleading, such as the illusion of irrigation canals in the 19th century, a seemingly fanciful concept championed by Percival Lowell and others. This raised public expectations for over 50 years, and there was still a belief in the canals up to the mid-1960s, when NASA's probes showed nothing. Interest was swiftly replaced with disillusion and disappointment. So here's Percival with this big, telescope and this observatory. Very powerful image, that, I think. And you can see the image there on the right-hand side where the canals, supposedly were or are. The thing about Mars is it's so ravaged and so devastated that I think the canals could actually exist, but the planet's been so absolutely destroyed so many times that they would actually be difficult to find, you know. But I'm not totally sold on the idea of the canals, but I'm not totally sold on the idea that they never existed in the first place either. I don't know. I'm kind of sitting on the fence on that one, to be honest. Uh, we would have to look more deeply. Ice, dunes, and storms. So Hancock states that even though the canal's idea proved to be a letdown, other Martian phenomena discovered by telescopic observations and photometric studies aren't so easy to dismiss. Amongst the most intriguing are the waves of darkness. Near the edge of the polar caps, a general darkening of the Martian surface often appears around the spring season as the caps recede, moving towards the equator in, quote, a distinct band of heightened contrast, finally dissipating in the opposite hemisphere. So this is what I mean about the whole idea of the canals. It could be that they're just below the surface because Mars is very tempestuous and it undergoes these storms all the time. And I mean, you look at the deserts of our planet, Earth, they're always finding things just under the surface. The thing about storms is they blow over all this stuff. And how many times the archaeologists, wander into an area where they think there's absolutely nothing, or there's maybe a construction project goes on and they find skeletons from God knows when. So the thing about Mars is it's so, like I say, it's so ravaged and so devastated and full of all these storms all the time, at least once a year, that the canals could really be there. It's just that we just have to look a bit more deeply. The Martian South Pole is measured to be the far colder of the two and is composed almost entirely of carbon dioxide ice. Mars' North Pole cap fluctuates in terms of the quantity of carbon dioxide ice, but has a permanent core of pure water ice 1,000 kilometers across and is the largest reservoir of water available on Mars. There are large layered deposits around the polar ice cap and beneath it. Hancock describes powerful Martian storms. Dust can be thrown as high as 10 kilometers into the atmosphere, often obscuring the surface for weeks at a time. And you might think to yourself, well, you just made that point, but I'm structuring the presentation as the book is written. So, I agree. Why didn't Hancock just, you know, put those 2 points together rather than make the point, make another point, then go back to the original point. Nobody's perfect. What can I tell you? So there's a good image of the dust storms, that encapsulate the planet. So you got the 2 dates there. What Mars looked like on May the 28th, and then what it looked like on July the 1st. I don't know what year that's from, but you get the point. And you can see the polar ice caps, the North Pole and the South Pole. Extraordinary surface features. So Mars is a planet of extremes. Its valleys are the deepest in the solar system and its volcanoes the highest. Olympus Mons is a shield volcano and is 700 kilometers in diameter at the bottom and 80 kilometers wide at the top. The outer edge of the lava scab had a circumference of almost 5,000 kilometers and sheer cliffs down to the plains below. The Elysium Bulge is to the southwest, surrounded by 3 volcanoes. The Tharsis Bulge, 1,600 kilometers from Olympus Mons, measures 4,000 kilometers from north to south and 3,000 kilometers from east to west. So have a look at these images. The Tharsis Bulge is a giant plateau with volcanoes built on it. I would say more like formed. I wouldn't say built. How do you build a volcano? It's not like building a shed. But anyway, imagine what does that say, Tibetan or Colorado plateau on Earth capped by volcanoes the size of Mount Everest, but they're all localized in one part of the planet. And I think visual images really help to put things into context. That's why it takes me a while to make these slides, because I'll go out my way to put the images in to show you exactly what I'm talking about. Extraordinary surface features. The 3 huge shield volcanoes are Arsia, Pavonis, and Ascraeus Mons, known collectively as the Tharsis Montes. On the eastern edge of the Tharsis Bulge, Mars was split open by a devastating catastrophe. Hancock describes a strange series of interconnecting box canyons and depressions, the Noctis Labyrinthus. A quote, meandering furrow opens to the east, opens in the surface to the east. This is the Valles Marineris, named after the Mariner 9 probe, which was first to discover and photograph it. It is 7 kilometers deep and 200 kilometers wide, making it 4 times deeper, 6 times wider, and 10 times longer than the Grand Canyon. So here's the images of the Noctis Labyrinthus and the Valles Marineris. Again, topographical images. And look, it's one thing to read it off the screen, 4 times deeper, 6 times wider, and 10 times longer than the Grand Canyon. It's another thing to actually see it. And I don't know if you can spot that on the image on the right, but the Valles Marineris takes up the entirety of the continental United States. Not just a tiny little part of it. It takes up the US, the continental United States, and more. It's actually longer than the continental US. So there you go. That's the true size and scale of this huge scar all across the Martian surface. Hancock compares the nightmarish landscape of the Valles Marineris to Dante's Inferno. The channels are all particularly wide and long, namely the Simid to and Eris Vallis, where the NASA Global Surveyor landed in 1997. These all run along the floor of the Cris Planitia basin, where they are joined by the Cassivalis Channel, running out of the north of the central section of the Marineris Canyons, 3,000 kilometers wide. According to Hancock, geologists all agree that these channels were caused by massive flooding from the southern hemisphere down into the northern hemisphere at an extreme rate. And again, visual images help tremendously in this regard if you take time to pause the video and study these images. So again, you can see the scale and the size of the Cris Planitia and the, how do you say this, Acidalia Planitia. And I think studying the maps and the topography really, really helps. So I went out of my way to put those images in, and you can pause the video anytime and really study these maps for hours as I have in the past, because Mars hugely fascinates me. A divided planet. So Hancock points out the huge contrast between the cratered southern uplands and the far smoother uncratered northern lowlands. Geologist Peter Cattermole explains that the two elevation zones between north and south are inclined at approximately 35 degrees to the Martian equator. The Elysium Bulge is located entirely inside the northern hemisphere, as is a large portion of the Tharsis Bulge. I've got that book on order, by the way, Mars, The Story of the Red Planet. It cost me 40 quid. But if that's what it costs, then that's what it costs. And look at the map on the right hand side, putting everything into context, where the Olympus Mons is, the Tharsis Bulge, the Valley Marinaris, those Mariner Valley in this particular image. And again, you've got the Tharsis Bulge and the Elysium Bulge. By the way, Hancock goes into more detail about all this in the book itself and later presentations. He fleshes all this out. In fact, The Mars Mystery is really a brilliant, brilliant book. Don't just rely on these presentations. Actually get the book, because I don't put everything into the presentations. I do have to leave things out, and he fleshes it out a lot more. This is kind of the summary version of what's written in the book. And also, it's good to reward authors for their hard work as well, of course. A divided planet. So within the southern high hemisphere are portions of the Valles Marineris, along with the two enormous craters Argyre and Hellas, which Hancock believes were caused by either cometary or asteroid impacts. The Argyre is 3 kilometers deep, 630 kilometers in diameter. Hellas is 5 kilometers deep and almost 2,000 kilometers in diameter. These are the largest craters on Mars, but Hancock also points out that there are loads of craters on the red planet which are 30 kilometers in diameter or more. 30 kilometers in diameter. And sometimes in excess of 200 kilometers in diameter. I mean, jeez, this planet was absolutely smashed to pieces, hammered. And again, images help. Look at the size of the Argyre basin and the Tharsis volcanic complex. And, you can see how truly devastated Mars has been and absolutely ravaged by comets and asteroids and all the rest, these cosmic terrors. And just to put things into proper context, you can see the image on the left, the Hellas Planitia. Well, okay, it's one thing looking at a topographical map. But have a look at the image there on the right-hand side. The Hellas crater takes up almost half the size of the continental United States. I mean, it's fucking huge. Look at the size of it. It even takes up a little bit of Canada and a tiny little bit of Mexico. But look at the size of it. That's taking up like multiple, states within America. It's absolutely freaking huge, you know? And again, Hancock actually fleshes this out in the book. I'll flesh it out in future presentations too, of course. I mean, it's just the Mars Mystery is just brilliantly put together. It does have slight flaws here and there, like it kind of jumps between points, but he's hardly the only author who does that. I mean, fucking hell. Look at Beaumont. But, he makes the point brilliantly. And again, this is just a summary version. The actual book itself is far superior to the presentations that I'm giving you. Anyway, so A Divided Planet. Hancock states that there are tens of thousands of smaller craters down to 1 kilometer in diameter, and over 3,000 wider than 30 kilometers have been counted. 3,000 craters wider than 30 kilometers. Let that sink in. 93% of these lie in the southern hemisphere. The largely uncratered northern hemisphere is several kilometers lower and than its cratered southern counterpart. Geologist Ronald Greeley called it one of, quote, the major unsolved problems of Mars. Hancock states that Mars was struck with a major cataclysm of horrific proportions, which he speculates resulted in the annihilation of its once Earth-like Martian atmosphere and ability to sustain liquid water. There's the image there on the left-hand side of what a potentially terraformed Mars would look like, or what it did look like in the past. It's, again, largely oceans. At least half the planet was oceans, or seas or bodies of water. And look at the image there on the right, current Mars map and the ancient Mars map. You know, big difference there. So, yeah, as always, leave your thoughts and comments below.